Hello everybody and welcome back. We're looking in this video at question number 2 in B part of our 2018 Canadian Intermediate Contest. A bag contains n balls numbered from 1 to n, and n is greater than or equal to 2. There are n times n minus 1 ways in which Julio can remove one ball from the bag and then remove a second ball. So we are caring about the order in which these balls are picked. N choices for the first ball, n minus 1 choices out of the remaining balls. Oh, they actually explain it. Never mind. I don't need to explain it to you. They're doing it for me. For example, when the bag contains 6 balls numbered from 1 to 6, 4 of which are black, 2 of which are gold, there are 6 times 5 ways in which you can remove 2 of the balls, and 4 times 3 ways in which both balls can be black. So they're sort of explaining how to do ordered counting. Okay, sure. A bag contains 11 balls, numbered from 1 to 11, 7 of which are black, and 4 of which are gold. Julio removes 2 balls as described above. What is the probability that both balls are black? So it's the exact same thing, sort of, did you understand this reasoning, and can you change the numbers? And absolutely we can understand the reasoning and change the numbers. What were the numbers, though? 11 ways to pick first ball. And then we have one less ball in the bag because we've picked one. So 10 ways to pick the second ball. Okay. And what they wanted 7 are black. So 7 ways to pick the first ball as black. And then there's one less black ball. There's still 4 gold ones in there. 6 ways to pick the second ball as black. So the probability, 7 times 6 over 11 times 10. We could divide by 2 on top and bottom and say this is 21 out of 55. I think the 7 times 6 over 11 times 10 would probably be a fine way to put your final answer, but you can show the calculation. Even 42 out of 110 would be fine. Okay, B part. For some integer g, greater than or equal to 2, a second bag contains 6 black balls and g gold balls. The balls are numbered from 1 to g plus 6. Fair enough. Julio removes 2 balls as described above. The probability that both balls are black is 1 out of 8. Determine the value of g. Okay. So we can do this a little faster. Number of ways to pick 2 black balls, or let's say pick both black. Both balls black, I think, might be the best way to say it. Both balls black is, well, it'd be 6 times 5. Number of ways to pick 2 balls. Well, we've seen before, it's the total number of balls. That's how many choices we have for the first one. And then we have 1 less ball, so we have 1 less choice. Right, just make sure our numbers line up. 6 and 5 for the black balls? Sure. Okay. So we are told 1 out of 8 is 6 times 5 over g plus 6 times g plus 5. So that's 30 over g. I'm going to leave it as g plus 6, g plus 5 for a moment. We could cross multiply. We'll get g plus 6 times g plus 5 is equal to 8 times 30, which will be 240. So now let's expand the left-hand side. We'll get g squared plus 11g plus 30 is equal to 240. Subtract 240 from both sides, and we will get 210. Can I think of 2 numbers that multiply to negative 210 that differ by 11? I think a 21 and a 10 should do. Which ones? 21 there, minus 10 here. So G is either minus 21. Minus 21 gold balls does not sound right. Or 10. So we'd have 10 gold balls. And if you wanted to, well, now that you know it's 16, you could say, so 30 over 16 times 15. 15 and 30 cancel out. We'll get 2 over 16. And yeah, that is 1 out of 8. So yeah, it worked out. All right, we got a little room for C part. What do we got for C? For some integer x, a third bag contains 2x black balls and x gold balls. The balls are numbered 1 to 3x, sure. Julio removes 2 balls as described above. The probability that both balls are black is 7 out of 16. Determine the value of x. Okay, well, number of ways to get them both black is 2x times 2x minus 1. Number of ways to pick 2 balls is 3x minus 1. And we're told that this is what? 7 out of 16. 2x minus 1. 3x minus 1. I'm going to cancel out the x's here. We can multiply by 3 and divide by 2 on both sides, so 21 out of 32. It's 2x minus 1, 3x minus 1, and I would say from there you could probably guess your way to x is 11, but we could also just multiply out. 63x minus 21 is 64x minus 32. Add 32 to both sides, subtract 63x's from both sides. We get x is 11. That didn't take too long. Anyway. All right. So now we just have one more part to go. That'll be D part. What have we got for D part here? For some integer r, we've got a fourth bag, 10 black balls, 18 gold balls, and r red balls. Oh, let's see if we can extend the concept a little bit. Balls are numbered from 1 to r plus 28, so they're all different number. This time, Julio draws 3 balls, one after another. The probability that 2 of these 3 balls are black and and 1 of these 3 balls is gold is at least 1 out of 3,000. What's the largest possible value for R? Ooh, okay. So we've got some options. We should explain our options. We could have a black ball, then a gold ball, and a black ball. Or we could have a black ball, and a gold ball. Or we could have a gold ball first. Because all we're saying is we're picking 3 balls and 2 black, 1 gold, but they don't say the order. So there's 3 possible orderings now for each one, for each case. There are, what were the numbers? It was 10 and 18, but were they in that order? Yeah, 10 and 18. So for the first one, 10 ways to pick the black ball, 18 ways to pick the gold, and 9 to pick from the remaining black balls. Or for this second case, 10, and then 9, and then 18. It's going to be the same calculation, but the order here in which we pick the balls does matter. And so this is 9 times 18 is 162. And then we put a 0 on the end because we also multiply by 10. So add those up. 60, 3 times 16, 48. So 4860. Uh, 4,860 ways to get 2 black, 1 gold. They did not specify the order there. Okay. And then we've got our number of red balls. So how many ways are there to pick balls completely? Right? Number of ways to pick 3 balls. R plus 28 times R plus 27 times R plus 26. I'm going to go ahead and expand that out. R squared plus 55 R plus, I have no idea what 28 times 17 or 28 times 27 is. 756, there we go. R cubed plus 55R squared plus 756R plus 26R squared plus 26 times 55 is 1430R plus 26 times, it'll be plus 19,656. We can group some of this together, so the 55 and the 26 is 81, and then the 756 plus 1430, 2186R. So I'm noticing this is a power of 3. This is very close to a power of 3, and this should also be very close to a power of 3. In fact, I'm just going to quickly investigate. 19,656. If I add 1, that should be a power of 3. Right? No. Why is... Oh, if I add 27. Because 26 is 1 less than 27. 28 is 1 more. So multiply them together. It should be 27 squared minus 1, and then you multiply that by 27. So 27 might very well be important here. All right, so our probability, 14, there we go, R cubed plus 81R squared plus, what was it, 2186R plus 19,656 has to be greater. That's at least 1 over 3,000. So what have we got? 486 times 3,000. So I want 14,580,000. Has to be greater than. I'm actually just going to turn it back to this. So we need R to satisfy this equation. We want the largest R to satisfy this equation. Okay, I'm going to rewrite this. Can I rewrite this? I'm going to say let X, no, they used X in the last question. Let's say S. Let S be R minus 27. Then this is S minus 1 times S plus 1. And that's S cubed minus S, which is a little nicer to work with. So, I don't know, take a guess. It's an educated guess, but let's take a guess at the cube root of 1458000. So I'll pull that up on my calculator. I do have a cube root function. I'm going to use that. You could also just raise it to the power 1/3 if you just have an exponent function. And that's about 244.29. So I'm going to guess an S around there might work. So if S is, what was it, 244? If S is 244, S cubed minus S is going to be, so 244 should definitely work because we square it and then we subtract that amount. So 244 cubed, subtract 244 is 14526,540. I suspect the next one might work, but I certainly don't think 246 will work. So let's try 245, cube it, minus 245, and I get 1470580, and that's too big. So I don't even need to bother with the 246. because this function's only ever increasing in terms of s from this point on. After s is equal to 1, it just keeps going up. Right? Is that true? Actually, s, I think a half, it'll keep increasing. Anyway, not important. So s is 244 at largest. But that's r minus 27, so at largest we got 244 plus 27. So r is 271 at largest. And there we go. We've explained our work. This was a reasonable guess. I should have written a cube there. But yeah, not too bad. As long as we're confident in all our calculations, everything seems smooth. And that finishes off D part. So we only have one more question to go, and that'll be B3. Feel free to join me for that in the following video. Until then, take care and have a wonderful day.